Text page 294. You guys are on blue notebook, page 357. Just continue your note from that bonus question. Okay, we're on lesson 6.4, quadratic formula. You need to have this formula memorized. Let me say it again. You need to have this formula memorized for your test because I'm not going to give it to you on your test. Memorize it. You will need it. So, let's relate this, and the way this is related to our standard form. So, when we have a standard form of a quadratic, and we are unable to factor it using the ways we did in Chapter 5, we're going to be using the quadratic formula to factor these, okay? So, remember, our standard form is y is equal to squared plus x plus. So we have our ax squared plus bx plus c. Okay? Now, from the standard form, I'm going to show you exactly where each of the coefficients go into the quadratic formula. So the quadratic formula says x, and that x is referring to the values of these. All they've done is isolated outside the equation now. They've done all the legwork for you, the algebra, and they isolated x and discovered that x is equal to, I'm going to fill in the a's and b's in a second. Okay? So we have our A. Oh, I should have wrote negative. Oh, that's not squared. And C. So, this is your quadratic formula. We have it all written out here. And this is what it refers to. First of all, our A's, so the coefficient in front of our x squared, we take that number and plug it into these two variables in the quadratic formula. So those are both our A's. Our B is plugged in here. And remember, when you plug it into the first B, that negative stays on the outside. So if I were to plug in -1, what does it end up being after I've calculated it? +1. That negative stays on the outside. Very good. And finally, there's only one C. We plug in that value there. So what they've done, like we said, is they've isolated what x is equal to. So we have two values of x. They did all the algebra and they brought it to the outside. This is our quadratic formula. So we're solving for what x is equal to. Okay? So this is when you use things like this. Let's use example 1. The real roots. So they've given us, what are they giving us? 2x squared. Let's call this example 1a. Plus 9x plus 6. I'm going to give you an idea of when you would use these. Because technically, the quadratic formula is solving for x. Now, we've learned the way to solve for x already. Does anyone remember? Dude. That solves for the x value of the vertex. No problem. I'm solving for just x. So the x-intercepts. How do I solve for the x-intercepts? Now, vertex formula that gives us a vertex factoring. If I factor this, I could solve my x-intercepts. So I'm going to quickly try to factor this right now. I take the factors of 1 and 2, and 6, 1 and 6, 2 and 3. And I know that their products need to add up to +9. So let's give it a try right now, quickly. Let's see, I got 1 times 1, 2 times 6, 1 and 12. That's not going to work. How about 2 and 6 and 2 and 1 and 1 and 6? So that's 2 and 6. Is that going to work? No, that's not going to work. Okay, let's try 1 and 2, 2 and 3. That's 2 and 6. Is that going to work? Nope. And 2 times 2 and 1 times 3, 4, and 3. Is that going to work? No. So the way we've learned to factor, I can't solve this question right now. I have no idea how to find the x-intercepts. We're going to learn how. So I can't solve it using the way we've done with our factoring, so I'm just going to get rid of it over here. Don't worry. It's all right that you wrote that. Write the note underneath. What I'm going to do now, you can just start underneath. I'm going to plug these values into our quadratic formula. Okay? So I'm going to write the quadratic formula underneath. I'm going to rewrite these in color just so you guys can make that connection. 2, 9, and 6. So obviously that's our C, our B, and our A. Okay? We're going to plug those into the quadratic formula. Oh, I think I know a fast way of doing this now. Okay, so we have our quadratic formula, and we have our quadratic equation written in standard form, and normally let's make sure we get our y out here. Blah, 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 y equals, okay. So what we're going to do now is I just have to plug the values into this formula. So as long as I know this formula, plug the values in, carry out bed mass. The only thing is there's a bit of work to it. So let's start off. Our x is equal to negative. My b is 9. So I plug 9 in for b, plus or minus. Just going to do the other parts quickly. Okay. And once again, my other b, that's also 9. So I replace both b's with 9. My a has a value of 2. Plug 2 in there. 2 in down there. And finally, 6 is C. So I plug 6 in for my C. So if you guys notice, B is 9 and B is 9. I plug the value of 9 in for both of the B's. A is 2. A is 2. I plug 2 in for both of the A's. And C was 6. So I plugged in 6 in for the only C. So now this equation, there's only one variable, the x. I'm trying to solve for that x. I just have to carry out bed mass. And according to bed mass, I'm going to deal with what would be considered the brackets first, or the exponents, and that's the square root. So I'm going to deal with what's under the square root. Let's carry this out. I'm going to do the rest in black now. So x is equal to, what does this 9 become? Negative 9. So we now have negative 9 plus or minus the root of, what's 9 squared? 81. All right. Now this, you can consider a negative. Okay. So think of it as negative 4 times 2 times 6. What is it? I think it is it? 8 times 6? Yeah. Negative 48. So it ends up being written as 81 subtract 48. Okay? And it's all above what? 4. Good. So we've already made our first step. Next step is I'm going to simplify underneath the square root. So x is equal to negative 9 plus or minus 81 subtract 48 is 33. Good, Jeffrey. Divided by 4. Now, I got to figure out what the root of 33 is. Okay, let's figure out what the root of 33 is. So, second function square root 33 is equal to 5.744, blah, 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 blah. We're just going to put it as 5.744. X is equal to negative 9. Here's where it gets troublesome, guys, okay? Plus or minus 5.744. Now you can kind of keep this as a bracket if you like, or it'll just help separate from the plus or minus. This is the important part. Now normally when I do, normally when we do our x-intercepts, how many of them are there? How many x-intercepts are there normally? 2. And just as a side note right now, what if there are 0 x-intercepts? Where's the parabola? No, there's still a parabola. It has no x-intercepts.
It's moved down or up, and it's opening the other way.
Very good, Ross. It's moved down or up, and it's opening the other way. So just do a quick side note from that. Here's your x. If I have a parabola like that opening up, does it touch the x-intercept at all? Nope, so I got 0. Or one going like this, does it touch the x-intercept? No, okay. Now what if I only have one x-intercept? What's happening with that parabola? The vertex. No.
Why not?
Okay? You'll learn that in grade 11. It's not a problem. Okay, that was just a quick side note. Just want to make sure you guys understood that. So, like we said, most of the time we have 2, and in this case I have a plus or minus. So what I'm going to do now is I'm going to split this into 2 equations, just like we had done in our factored form, where we set the 2 equations equal to 0. This one, we now have x is equal to -9, and I take the plus 5.744 divided by 4. So that's one of the equations. The other equation is x equals -9 subtract 5.744, go get it fixed, divided by 4. Okay? So I'm going to solve both of these now. X equals 9 plus that answer is -3.255 divided by 4. X equals, I'm going to quickly just divide those. Answer divided by 4, negative 0.81, let's say 3. So that's one of my x-intercepts. My other x-intercept is x equals -9 subtract 5.744. It gives us -14.744 divided by 4. X equals, take that answer. Answer divided by 4. -3.686. So I have 2 x-intercepts. I'm going to quickly just grab a graph here. I can expand this to full now. So, I'll make sure those are 2 answers. Yeah. Okay, so I got to plot these as x-intercepts so that they make sense to me. So I have -0.83. That's somewhere around here. Okay? I'm guesstimating on the graph. And -3.6, that's somewhere around here. Okay? So I have like 2 x-intercepts now. I've solved for my x's. If they ask me to graph, we know that those are our r and our x, and we can do the rest. Okay? And we're going to get, it's not that even of a number. We're going to have decimals, but that's fine. I can still solve for this parabola because not every parabola is going to fall on an even number to work with. Okay? So that's how we factor questions. Quickly give you a full view. Using the quadratic formula. Whew. Lots of that page, eh? Let's quickly zoom in a little better here. Yeah, I have all the space in the world, don't worry. Okay? So we started up here. Slowly moving down. Look how smart we are. Ta-da! Okay?